All right, so let's move on to a new topic. We're talking about solving rational equations. Remember, rational is a fancy name for a fraction, which means these equations are involving fractions. Now, there's a couple of different ways we can go about solving that. Okay, I'm going to show you one way that I think works for most people. So here's the deal. Let's look at problem number 1. They're asking us to solve. Anytime we see fractions, especially with addition, what's the first thing we think about doing? Yeah, we think about getting a common denominator. So that's going to be my first suggestion, is get a common denominator between a 3x. By the way, even though this one doesn't look like a fraction, it is, isn't it? Yeah, it's over 1. So I need a common denominator between a 3x, a 1, and a 6. Go ahead and get it. I'll wait. Okay, did you find the common denominator? What'd you get? Good, I got the same thing, 6x, right? So that means I want to make certain that each one of these denominators is going to be a 6x. So now we have to see what we multiply by each denominator to change it to a 6x. So this first denominator, 3x, what do you have to multiply it by? Yeah, you're going to have to multiply it by a 2, which means the top as well, right? Which means this first numerator turns into a 10. Agreed? Okay, the second fraction, what do you have to multiply the second denominator by? Yeah, you definitely have to multiply it by a 6x, which means you have to multiply the numerator by the same thing, which means that second numerator is a 6x. And what about this third one? Yeah, it's just missing an x, so top and bottom by an x. And so this is what I have. Agreed for the third numerator? Okay, awesome. Now let me ask you a question. Is it quicker to solve an equation with fractions or without? Mind you, I didn't say easier, I said quicker. Yeah, without, I agree. So here's the thing. What operation is keeping this denominator attached to this numerator? Right? What's the operation between each of these denominators and their numerators? Yeah, each of those is division. So to break a division, what do we have to do? Good, we have to multiply. So if I take this first fraction and multiply it by 6x over 1, wouldn't these guys cancel out? Yeah, they would. So I think I'll multiply each of these fractions by 6x over 1. And when I do that, each of these denominators will cancel out, won't they? Which means I am going to be left with the equation 10 plus 6x equals 7x. Do you agree? Awesome, so do I. And now I've got something extremely simple to solve. So move the 6x to the other side, I end up with x equaling 10, don't I? Awesome. Cool? Okay, so recap. The first thing we did was we got all the denominators to look the same. And so, second thing we did is figure out what we had to multiply each denominator by, so we could do the same thing to those numerators, right? Third thing, we multiplied each fraction by that denominator to cancel them out, right? And then we were left with a nice simple equation to go solve. Cool? Okay, so for you step people, rewind the video and go back and write those steps that I had mentioned that we did for problem number 1. Why? Because we're going to do the exact same thing for problem number 2. Cool? Okay, so here we go on problem 2. First thing we need is a common denominator. So what's a common denominator between an x plus 3 and an x minus 3? Good, it's x plus 3, x minus 3. It's both of them multiplied together, isn't it? So I know each fraction is going to have this denominator. And I know some of you are going, yeah, but there's no addition or subtraction between these guys. You're right, there's no addition or subtraction between these two fractions. But here's the deal. It is an equation that contains fractions. And the process that worked over here is going to work for any equation that contains fractions. So even though I don't see addition and subtraction here, I'm going to use the exact same steps on problem 2 that I did on problem 1. Good? Okay, So now, here's the first denominator. What do we have to do to it to make it look like the common? Yes, I have to multiply it by x minus 3, not just the denominator, but also the numerator, right? And on this one, that's right, we have to multiply by x plus 3, which means, agreed? Okay, so if I do this distribution, well, let me just write this here. Okay, so then, help me out. Is it quicker to solve an equation with fractions or without? Without. So, I need to get rid of each of these denominators. What's the operation keeping these guys together? Good, division. So how do I break division? Excellent, multiply. So I'm going to multiply each fraction by this common denominator. And when I do, that common denominator is going to cancel. And on this side, I'm running out of room, right? But these will cancel out. Got it? Which leaves me this nice simple little equation to go solve. Now, you could have done the distribution here when you were writing the numerators, or you could have waited and done it here. Regardless, you're going to get the same answer. So, I need to work on that distribution. I need to bring my x's to one side. I'm going to move them to the left. So what do we get? Good, we got 2x. And then I need to move that 18 to the other side, right? And then I finally get to divide. And that's what I got. Did you get the same thing? Awesome. Okay, now, again, first step is get the denominators all the same. Second step, see what you need to multiply each of the denominators by, so you can do the same thing to the numerators. Third step, cancel those denominators. And then last but not least, solve the nice simple equation you have left. Now there's one last step on these particular problems. You're like, what can that be? Well, after we solve an equation, what do we normally do next? Yeah, we normally check, right? We normally check it back to the original problem, don't we? Okay, so I am going to erase my little work here because I want to see what the original problem was for both of these. Now, when we check, we take our answer and we plug it back in for, in this case, x. Because in both problems, my variable was x, was it not? All right, so go to problem 1. What answer did we get for x? Yeah, we got 10, didn't we? Now here's the deal. I know we normally don't check anymore because we're like, hey, we're pretty confident in our solving abilities. Why do I need to check? Here's why you need to check. I need to make certain that this answer does not make any of my denominators equal to 0. Because remember, the one number your denominator is not allowed to be is a 0, is it? So, in this case, I have 3 denominators, don't I? I have a 3x, I have a 1, and I have a 6. And I need to make certain that when I plug this 10 in, it doesn't make any of these denominators a 0. Well, clearly, for these last two, these are good to go because there's no x's next to them. So this one will always remain a 6, and this denominator would always remain a 1, wouldn't it? But that first denominator has an x. And so I've got to plug that 10 in here, and I need to make certain that this is not equal to a 0. So when I take the first denominator and plug the 10 in for the x, I get a 30, which is good to go. It's not a 0, so yay for that. Because if your answer does make any of the denominators a 0, you can't use it. With me? Okay, so the 10 is good to go. Check, it didn't make any denominator 0. We're good there. Let's look at problem 2. I've got 2 denominators, right? I have the x plus 3 and I have the x minus 3, and my x is 15. Well, if I plug the 15 into the first one, yeah, we're okay there. That's not a 0. If I plug the 15 into the second denominator, yeah, we're good there also. That's not a 0. So this answer of 15, we're good to use it. Got it? Yeah, this is the last step that must be performed when you're solving equations that contain fractions. So, hang in there. Got some more problems for us. Let's look at this third problem. Okay, so I have an equation that contains fractions. What's the first thing I have to do? Good, I got to find a common denominator. So, let's work this one out on finding the LCD, shall we? All right, do you remember what I mentioned in a previous lecture? Yeah, we're going to have to factor, aren't we? Well, the first denominator, it's already done. I don't have to do anything to that. The second denominator, it's already done. But that third denominator needs to be factored, doesn't it? Okay, so what do you get? That's the first one. That's the second one. Here's the third one. What do you get when you factor that third denominator? Pause the video if you need to. Go factor it, and then start it again, and let's see if we agree. Okay, so here's what I got. When I factored it, I got... Did you? Cool. Okay, so here are my three denominators, and I need to make them all look the same, don't I? So, it looks like this first denominator is missing what? Yeah, it's missing the x plus 4, isn't it? And the second denominator is missing the x minus 2. And the third denominator already has both of them, so I don't have to be concerned about denominator 3. Cool? Okay, which means over here, we said this first denominator is missing the x plus 4, isn't it? Which means I have to multiply top and bottom by x plus 4. Right? And the second fraction, what did we say its denominator was missing? Yeah, the x minus 2. Which means we have to multiply the numerator by that x minus 2 also, correct? And then number 3, it wasn't missing anything. So let's write down what this looks like, because it's a little messy looking right now. When you do this, what's the numerator look like here? You're doing 5 times that parenthesis. What do you get? Good. 5x plus 20. Awesome. Over these two parentheses, right? Okay, and then I'm subtracting. What do I get here when I do that distribution? Good. I get 2x minus 4, don't I? Over, right? Equals negative 4 over. Now, I'm going to write fraction 3 in this factored form that we got earlier. Good? Making sense? Okay. Now, some of you may go, well, you know, instead of doing this distribution, could I leave it like this? And absolutely you can. And you know what? Nah, we'll leave it this way. Okay, so now, we found the common denominator. We made sure they all looked the same, which means if we had to multiply the denominator by something, we did the same thing to the numerator, right? So we did the first 2 steps, and now what? Good, get rid of all 3 of these denominators by doing what? Yeah, multiplying by the common denominator. So all 3 of these are going to get multiplied by this parenthesis, right? I'm going to do it to fraction 2 and fraction 3. Agreed? Which means all 3 of these denominators are going to cancel out, aren't they? Awesome. So let's write down what remains. So the first one, we have 5x plus 20, don't we? And then we have this minus sign. And hopefully, if you've seen some of my other video lectures, you have to be careful about the minus sign. Because if there's more than one term following the minus sign, you're going to have to distribute that minus sign, aren't you? So my recommendation is to open up a parenthesis and write down what is supposed to follow the minus sign So you remember that if it's more than one term, to distribute the minus sign. Cool? Okay, and that equals -4. Got it? Awesome. Okay, let's keep working it out. We're doing good. See, we knew it was a -2x, but this is supposed to be a +4 on that side. With me? Okay, collecting like terms over here on the left. Moving that 24 over, and then dividing by 3. Did you get the same thing? Good. So help me out here. Is this my final answer? Yes. Am I done with the problem? Not quite. Why not? Yeah, because you have to check it, don't you? Okay, so we have to check and make sure our denominators are good. So one of my common denominator was made up of an x minus 2 and an x plus 4, right? So when I take my answer and I plug it in, the question is, do I get 0 here? Yeah, you sure don't, which means this answer is good to go. Cool? I have to make sure, I have to check it. All right, got another one for you. Let's look at this last problem. So, I have an equation that contains fractions, correct? What do I need to do? Good, find a common denominator, right? Okay, so what's the first thing I do to find a common denominator? I factor. So, to find our LCD, denominator number 1, well, that one certainly needs to be factored, doesn't it? Okay, pause the video, go factor it, come back when you're done, and let's see if we agree. Okay, you get your answer for this factoring? Okay, so my factoring on that first denominator looks like that. Do you agree? Okay, denominator number 2, already factored. Denominator number 3, already factored. Well, that's nice. Okay, and then we have to make them all look the same, right? So, denominator number 1 clearly has both of these. So it looks like the second denominator just needs to be multiplied by x minus 1, and the third denominator needs to be multiplied by 3x plus 2. Now, some of you may be asking, hey, the last problem, we kind of had the same situation, and the one we had to factor was like made up of the two other ones. You know, that happens a good majority of the time. I would say a good, 95, 97% of the time. So yeah, but be careful because there's that 2 to 3%, doesn't work that way. So be really careful. Got it? Okay, so denominator number 1 didn't need to do anything to it. Denominator number 2, we had to multiply by x minus 1, so I need to do that to the top and bottom. And denominator number 3 needed to get multiplied by, 3x plus 2 to the top and the bottom. Cool? All right. Let's see what we got. So, we have 4x squared minus 24x over. And I am just going to rewrite this first denominator in its factored form, make it look like everybody else. Okay, and then I have the second numerator, and I'm going to leave it this way. Some of you are going, well, can't you distribute it? Yes, you can. And some of you don't want to distribute yet. So, the last problem I distributed the numerator here. In this problem, I'm not going to. All right, just so you can see it both ways. Here is its denominator, and the third fraction looks like this. Okay. Found our common denominator, multiplied each fraction by what we needed to, and last well, not last, but next, we got to get rid of all these denominators, right? How? Good, we multiply by the common denominator. So the common denominator is the quantity 3x plus 2 times x minus 1, and that's over 1, right? So I don't multiply it to just the first fraction, I have to multiply to all three, which ends up canceling all three denominators. With me? Cool. Okay, again, if you've got to pause this problem, go back to the beginning and look at it again. Make certain you do that. Do that for the entire video. Got it? Okay, so what remains? I have 4x squared minus 24x plus 3 times this parenthesis equals negative 4 times this parenthesis. All right, ready to do some more algebra? Let's go. Distribute first, as you well know. Now what? So we do collect terms, collect the same terms on the left-hand side here. Right? Okay. Now what? Yeah. Whoops. Did you catch me? I added wrong. Hey, that's why you guys have to do the work with me. Just in case. Yeah, I should have been a 21. Okay. Now what? Some of you aren't sure. Some of you want to move stuff to the right, some of you want to move stuff to the left, and some of you are scratching your heads going, now what? Okay. There is something written on this line that tells me what I have to do. What is it? This x squared. You're like, what does that tell you to do? How do we solve equations that have an x squared in it? What did we do in the previous lecture? Yeah, we had to factor. You see that x squared? That tells you that you're going to have to factor. And to factor correctly, it must be equal to 0. Which means you're going to have to take everything from the right and move it to the left so it equals 0. So you can factor it correctly. Got it? Write that down for yourselves. That x squared tells you to factor. But before you factor correctly, it must be equal to 0. Cool? Okay. So we have 4x squared. We have the 12x over, which is going to give me that negative 9x. I add the 8, which will give me a positive 5. So far, so good? Okay. I am going to continue the problem over here. Why? Because I ran out of board space. And now what do we have to do with this? We're going to have to factor it. So, pause the video, you go factor it, and see if we agree. Okay, this is what I got. Okay, that's what I got when I factored it. Did you get the same thing? I hope so. Okay, so then remind yourself, after we factor, what do we do next? Good, we have to take each one of those parentheses and we have to set them equal to 0, don't we? All right. So 4x minus 5 equals 0. Move the 5 over, divide by 4. We get one answer of x equals 5/4. Set the second parenthesis equal to 0. We get a second answer of x equals 1, don't we? Okay, are we done with this problem? Nope, we're going to have to check it. We're going to have to check these answers and these denominators to make certain that none of my denominators end up as 0, correct? Okay, so recall, so we're checking the denominators. Recall that each of these common denominators, right? Each of these denominators was made up of a 3x plus 2 and an x minus 1, correct? if I take 5/4, so here's my first check. If I take the 5/4 and plug it into here, is that a 0? Nope. If I take the 5/4 and plug it into this one, is that a 0? Nope. So the 5/4, good to go. What about number 2 here? Answer number 2. I'm checking answer number 2, and that answer is a 1. If I take the 1 and plug it in, do I get a 0? Nope. Into the second one, if I take the 1 and plug it in, does it make this one 0? Yep. That 1 makes this denominator a 0. Can I use this answer then? Nope. I have 2 answers. I did everything right. I have 2 answers, and one of the answers isn't working for us. In this case, I have 1 answer that works, and it's this one. This will be the only answer for this particular problem. Cool? Okay. And you're like, well, what happens if both of them didn't work? Then you got no solution. Okay? All right. Okay. So, this problem was very good. Why? It made you do a lot of the previous stuff that you've done before to refresh your brain. It made you find the common denominator, which we did, right? And then we did some of our new stuff, and then we saw this line and said, uh-oh, in order to solve this, we're going to have to factor, and to factor, we're going to have to set it equal to 0, which we did, and then we had to go and check. This was a really good problem. So, as I mentioned a little bit ago, I suggest rewinding this video and going back to the beginning and making sure you understand this process. Because no matter how ugly the problem looks to you, the process never changes. You have fun with solving rational equations, and I'll catch you on the flip side.